These that I asked you to do because, of course, they're all the same. And then we'll get on to the wrinkle part of this. I'm going to do 1C because it's an angle. They're slightly more difficult. Sine theta over 12 equals sine 50 over 65. Cross multiply as always. 12 sine 50 over 65 equals sine theta. To get rid of that, you do shift sine. And the answer is whatever it is, because that's the important part. In number 2, they're always the same. You want this length right here, little a. So sine 88 over 44 equals sine 35 over little a. Or little a over sine 35, depending on which way you're comfortable with. 44 sine 35 divided by sine 88. Shouldn't be a problem until number 5, when you got to draw it yourself. So, number 5, just draw a triangle. A, 57 degrees. B, 73 degrees. Now you automatically know C. AB was 24. You had to find the length of AC right here. So you know this angle because it's 180 minus 73 minus 57, which is 130, so that is 50. There's your pair. Sine of 50 over 24 equals sine of 73 over little b, and then you solve. Everybody should be good with these, right? It's one step till we get to word problems. Then you just gotta draw what you have. But everything you draw is going to be what? Triangle. So just draw a triangle. First one's not too bad. There's the stadium. Maria is north of the stadium and can see the balloon at an angle of inclination of 64. You should remember that from grade 10. Inclination means up, yes? So the balloon is up here. What's the girl's name? Maria is down here. She sees the balloon at 64. The horizontal Roy sees the balloon at 49. 49. How far apart are they? Since you know this automatically. They are 500 apart. You know that angle. There's your drawing. Determine the distance that the hot air balloon is from Maria, right there. You would do this to be 104, 9 is 113, so this is 67. There's your pair. You need this side, little r, sine of 49 and little r. All right? I don't want to spend a lot of time on this because sine law is really easy until what we're going to talk about today. All you do is find your opposite pair of side and angle and do the fractions. Okay? Okay. Turn to page 212. Now on 212 you will notice the title says ambiguous triangles. What does the word ambiguous mean? Does anybody know? Huh? Kinda. Ambiguous means you're not sure. Okay? So, let's draw some of these and you'll see what I mean. Draw this triangle. All right, let's draw it. Everybody cool? That triangle, we're all happy, yes? But it says it's going to be ambiguous. So we don't know what this triangle is really going to look like, do we? So in these cases, we got to do this. What is the only thing I know when I read that? I know I've got an angle of 30 degrees. Yes? And I know that angle is angle A. Yeah? All right. Now, I'm going to put B up here, which means I now know that this is 6. Yes? If this is A and this is B, here would be C. Agreed? Now, according to our question, BC is 3. Does everyone agree? All right, now let's have a look at this situation. If that is 30, then what is this right here? 90, because I've dropped straight down, and this is 60. Is everybody cool? Is this a possibility of the triangle that we might be drawing? Is this possible? It is, right? Because we already know that if this is a 30, 60, 90 triangle, the hypotenuse in a 30, 60, 90 is 2, right? If this is 30, then this is 1. And this would be root 2, right? Yeah. Everybody's cool with that? So this is possible. Now, because they're ambiguous, we have to check. Here's how you check. Would it be possible to have this triangle? Could this be A with 30? Could this be 6? But then C would be way out here, wouldn't it? Is that possible? If this isn't here, is this green a possible triangle? Yes. What if is this blue a possible triangle? Could this still be 30, this 6, and then have that blue there? Is that possible? Yes. And, of course, the red is possible, because we just proved that, right? So now all of you should be aware that if I have a degree here, any degree here, and this value, then I have 1, 2, 3 possible kinds of triangle, don't I? And that is why this is ambiguous. All right? Now, here is how you work it out. You set up what you know, the angle and one of the sides. Then you check it against this side. And I'm going to change colors. What haven't I used? I've used blue, I've used red, I've used pink, gray. This third side is where the issue is, yes? Because it could be in 1, 2, or 3 spots, yeah? So here's what we do. We check this side. Now, here's a theta, right? What is every single sine of theta? It's always what? Opposite over hypotenuse, yes? Now in this fake triangle here, because we're still not sure, what do I know here? I know theta, sine theta, equals this distance, right? What do we do? What do we give it when we don't know a distance? we give it a letter. We always use X, Y, whatever, right? I don't care what you want to call it. I've been calling this Q because that's an altitude, yes? So Q over what? 6, right? Now, I don't need to write theta here because I know what theta is. What is it? Now, how would you get Q isolated? 6 sine 30 would equal Q, yes? Okay, well, when you do that on your calculator, what do you get?
You get 3.
3 equals Q. Everybody understand? All right. Now this is telling me Q equals 3 and a... Okay, so now we're good, right? Now how many options do we have for a triangle? Just the one, 30, 60, 90, right? Because this has to be 3. Everybody understand? All right. So, when my third side, actually, no, we're going to come back. We're going to do that in a minute. Everybody understands what we did, right? We took the side we knew, the angle we knew, and we found the third side. Everybody cool? All right. Now do this, but do it with these parameters. So what's it going to look like over here? 36AB. We're cool, yeah? Everybody understand? Same start, yeah? So I got to check on Q here. We know that Q would be 3 with a 30 and a 6, yes? We know this is AB, so what does that make this corner here? C. Now, this question says BC equals 2. But how long does BC have to be? 3. Is this possible?
I would want to say no, but I feel like it is.
Okay. B to C is 2. Right? Says so right there. How long does B to C have to be to make an actual triangle? 3. Is B to C 3? No. So this would look like this. 30. And what would happen here? Would it get all the way down? No. So in this case, BC equaled 3. If Q equals the third side, can we make a triangle? What kind of triangle? A right triangle. If Q equals the third side, we can make a right triangle. Everybody cool? No argument. It has to be a right triangle because this distance has to be 3 because we've already proven that, right? All right. Well, what's happening here? How does Q 3 compare to the third side? Right. So if Q is greater than the third side, what happens? It's not going to reach, is it? So can we even make a triangle? No. Q is greater than the third side. There's no triangle. Right? Because it'll just be swinging. Everybody cool? All right. Now we get to the weird stuff. That wasn't the weird stuff. How are we going to draw number 5? We're going to start it the same way, yes? So let's start it the same way. What's here? A, B, 6. Everyone agree? Okay. Q is here, yes? Oops. We know Q is 3, right? Well, what's the third side of our triangle? 8. Everybody cool?
No.
Now, if the third side of our triangle is 8, and I will draw it in green, it would go all the way down to here, wouldn't it? Is that a triangle? No. So right now, Q, right, is less than our third side, right? Everybody's cool? That doesn't make a triangle. Now, could I take this third side, which is going to be a green line, could I put it out here? I could, right? Because it was swung down here, but I could swing it out here, yeah? And that would make this triangle. Because we don't know how long the bottom is. Does everybody follow me? Okay. So remember, on the very first question, we said the triangle could be straight, could be there, or could be out there, right? So we're happy with it out here, yeah? Could it go here? No, why not? Because 8 is longer than 6, isn't it? Everybody with me? So we've got a problem here. Q is less than my third side, right? Which means I can swing the triangle out to the right. Can I swing it back to the left? No. Now here's the problem. We're saying right and left because we're looking at it with right and left, yes? But this triangle could be spun around, couldn't it? So here's what I got to think. If Q is less than my third side, right? Pardon me? It has to swing away from the side we know. Everybody with me? Making this really big angle. What do we call that angle when it gets bigger than 90? Obtuse. When Q is greater than the third side, all right? And, actually, we're going to wait a sec. We're going to draw one more triangle. Down here, let's draw it. What do we get? 30, 6, A, B. Now, what's the problem? How long's Q? 3. How long's the third side? Is 4 greater than 3? So, would it be possible, and I'll use another weird color, is this a possible triangle? It is, right? Is this a possible triangle? Why, yes. Because it's close. It can't be more than 6, though, could it? Because with 8, when we took this green triangle, or this green line, if we swung it this way, no triangle, yes? If we swing it straight out this way, it's still longer than 6. But what happened here? 4 is less than 6, isn't it? So I could have this triangle with a big angle, or I have this triangle. That's the weird thing. So Q greater than the third side, no problem. Like Hayden says, I got to swing away, and it makes 1, that should be green, 1 obtuse triangle because of that angle. What's happening down here? How does Q work? So when Q is greater than the third side, and what? Right. When Q is greater than the third side, and the third side is less than our known side, what happens? We get 2 triangles. Ambiguity. We are not sure. What is the only thing that's in all of them?
Triangles. The 30-degree angle on this.
What if it wasn't 30?
The angle on this side.
Like, what if this was, say this was 47, and this was 6?
Still get an angle.
I would still get, not an angle, I would still get I still got to find my third side, right? What is the thing that determines which of these triangles I'm getting? The sine of what? The sine of theta and what value? What is in all three options? What is that distance? The altitude. I've got to check the Q because that third side can either fit perfectly, have to stretch way out here, or not reach at all. So what do I always have to find? I always need an altitude, which we define as Q. And Q is always the hypotenuse, or what might be the hypotenuse, times sine of theta. Right? So now, let's go back to one of those questions that I told you not to do. The first one that I said not to do was number 6, right? So let's look at number 6 together, and then I'm going to get you guys to do the questions that I told you not to do. Everybody cool? So let's look at 6. 6A. In triangle ABC, A is 39, angle A is 39, small a is 10, big B is 14. So let's draw it. There's my 39. Everybody cool? Which means that gets what letter? Big A, right? Now, where would I be allowed to put B? Could I put B up here? Just yes or no? If I put big B there, then what does that make this side? Little b, and what does that make this third side? And I'm going to do that third side because we don't know where it's going. What would that make it? Little a. Now let's stop and think for a second. Do I know that? Read the question. I know that it is 10, yes? Do I know that? It is 14, right? Yeah? Everybody cool with what I've drawn here? Now, let's change something around. What if I make this side B? Is that cool? So what does that make this? 14, and what does that make this? 10. Which of those can I work with? Because I have to find out if the triangle is possible. Can I work with yellow or blue? I need the blue one, don't I? Because the blue one is the one where I can check for my altitude, right? Because how big is this? How big is A? Which means that blue line right there would be my Q, yes? And 14 sine 39 would give me Q, right? What is 14 times sine 39? 8.8. So if this is 8.8, which I'm going to draw in now, and the third side is 10, could this third side go straight down here? No, because it's longer than 8.8, right? Everybody agree? Could it swing over here? Why, Jacob? Because it's smaller than 14, right? If I made the third side of this triangle, we know this is 8.8, right? And I have a third side of this triangle that we know to be 10, right? Because it's opposite A. 10, yeah? All right. So I know this is 8.8. So it can't go there because it's longer than 8.8. So we know this isn't a right angle triangle. What happens if I put it here? Is 8.8 shorter than 14? Yeah, so it could swing back this way, right? Red. I want red. Yes? And 8.8 is shorter than 10. So since it can't go down there, it could also go out there. So I could have this triangle, or I could have this triangle. Does everybody understand? You have to check the altitude. So always set these up with the angle you know and the side you know, one of the sides you know right here. Okay? One known side. Then seek that distance. Everybody cool? And I know it seems confusing, but all it comes down to is sine, right? I'm going to do one more because there's a whole bunch of these on here that I told you to skip. ABC. Here's the angle we know. It's 123 degrees now. Now we're getting weird, yeah? There's A. Little a is 23. B is 12. Damn. Myers says I got to check the altitude. Wouldn't that be right there? So if this is 23, what's this? If this is 123, what's this? How much? 47? 57. Why, Gravere? Right, this is a lot like a reference angle, isn't it? So this is 57, yeah? Everyone agrees? Now, where did I tell you to put the side you know? Attached to this, yeah? So what am I going to make this? No, this orange line here. 12, right? How does that allow me to check Q? What is Q? It's always 12 times the sine of the angle we've got, yeah? So what's Q? $10 something, right? Yeah? Whatever. I just wrote 10 degrees.
10.06.
Well, 10.1, right? Okay. So, if that's 12, can we make this triangle? Okay. Can we make a triangle like this? If that's 23. What are my only... Okay, I'll change the question. I'm trying to work on my questioning for you guys. Where must 12 be, or where must 12 be right now? Where are the only choices it could go? Could I put 12 there? Could I put 12... I don't want to use yellow. Could I put 12... I've already used orange. Could I put 12 there? They're both possible, yes? All right, so I need that altitude, yeah? So we found this altitude to be 10, right? 10 point... So 10.1, yeah? So if it is 10.1, then could I use that to find this theta in here? Could I use 12 and 10.1? I can, can't I? So that would make this, we already know because of this that that's going to be 57, right? So can that be 12, that be 23, and that be some other number? Of course it can, because that's okay, right? We don't know that third side. Yeah? Okay. So what if I do this? I make this side 12. Everyone cool? Okay. I'll make that a better 123. Make it bigger. This side's now 12, yes? Everybody cool? Okay. So, if this side's 12 and this side's 23, then all I would have to do, since I know that this side works, and this has 123 degrees, doesn't this side, wouldn't that just make the triangle lean up that way? Look. You all agree this could work, yes? Right? That makes this short and this side long, yeah? Is this side going to be longer or shorter than 23? Why? Because 23 is the biggest side. It has to be, because this is over 90 degrees, right? Okay, so this side has to be less than 23, right? Okay, if this side is less than 23 and that side's 12, isn't it also possible that this triangle would look like this? Less than 23 and 12 there. Aren't they the same triangle? So how many options were there? One, because it's just the same triangle turned because of the 123. Right? So now, and I stress, I'm reminding you, this is called ambiguous triangles. There's trouble here. So I think we should probably do all of 6 before I let you go and do the other ones. All right, let's try 6 again. Okay. Oh, I know what would help. I know how to handle this better. Yeah. Maybe this will help. Let's put A there and see what happens. So what would I write here? C, 145. Everybody cool? Okay, so what is this across here? 18. Across from A, yeah? Okay. Then, where can I put B? Either one, yeah? If this is 10, then this is going to have some distance, right? Okay. So let's make it, so that would make this side B, right? Okay. Now let's look at this. Forget ambiguous triangles. Is there something you can do with this? Think of what we did on Friday. Is there something you can do with this triangle? What? You could split it, but don't say split it in two. We could draw a Q, yeah? Now, there's a problem with drawing that Q, right? Because does that Q split this into 9 and 9? No, we don't know. Does that Q split this into 72 and a half? We don't know, do we? So that Q is a problem there. But again, think back to Friday. What do you see? Do I have 18 over sine 145? I do, don't I? Okay. And that would equal what? 10 over sine B. This is a better way to do this. Now what would you do with that? 10 sine 45 divided by 18 would equal sine B, right? If I do that on my calculator, 10 sine 145, right? I wrote 45, but it's 145. Divided by, gets me a number, shift, sine. I forgot to do shift sine first, but that's okay. So now how big is B? 18.58, so 19, right? Do we all agree? So 145, 19, which would make this what? $17. Be 16, wouldn't it? 145 and 19 is 165, 164. So that'll make that 16, yeah? Okay, so now 16 and 10, right? What is 10 sine 16? 2.75, yeah? Now you guys are smart kids. 16 and 19 are pretty close to the same number, yeah? So that means this must be pretty close to an isosceles triangle, yeah? So this number must be pretty close to 10, yeah? And what was our Q? 2 point whatever, right? So this is 2.75, right? This side is 10-ish. Has to be way out here, doesn't it? So there can only be one triangle. So when you have these big numbers, you just got to think, how's it going to look? Have a look at D. Is D possible? 124 would be A. The other side would be 1. Right? That's the biggest side, right? Biggest side is 1. The other side is what? So, is it possible? That one is no. Does that help? That helps? Okay. So, bring all your knowledge to the party. If you see a bigger than an obtuse, you know that whatever's across from it has to be the biggest side, right? Is 23 bigger than 12? So is it possible? Is 18 bigger than 10? So it's possible, but this one isn't. Is everybody good now? All right. So now I want you to check 8 and 9. Oh, I forgot to tell you oblique means obtuse. So that is an oblique triangle, right? Because here is an obtuse angle. And that is an oblique triangle, but where's the obtuse angle now? A, B, or C? C. But remember, if I spun this triangle around, it would look like this, and the obtuse would be at the top, right? So check 8, 9, and 9, 16, and 17. That's your job today. 8, 9, 16, 17. And that'll cover today. Now listen. Weather people don't know what is going on with the weather. And they're paid money to figure it out. Chilliwack was supposed to get 5 centimeters of snow yesterday. They got that much, which is 4 times what they forecast. These guys don't know anything. All right? It's supposed to be slightly snowy and rainy and minus like 20 overnight. Arctic outflow and winds. If more stuff falls and it stays that cold, then even Abbotsford is going to be a skating rink tomorrow. Which, just stop for 2 seconds and then you can cheer. If that happens, as Jacob pointed out on Friday, we are coming down to the end of the year, right? Last year, at the end of the year, they added a unit, inequalities, that I didn't know I had to do. We put it in, and now we're under time constraints. If this happens, I know none of you are going to do it, but I'm going to say it anyway. On any day school is canceled, I'm going to put a lesson online. Okay? You got to watch it. Everybody understand? There are schools in the world where they do that for every lesson because kids never do homework. So they don't bother giving homework. They put the lesson on a video. You watch that. That's your homework, 20 minutes. Then you come in the next day and you work on it. All right? You got to do it if school's been canceled. So that morning, school's canceled. Oh, I still got a math class. It's just going to be on the video. All right? All of you have access to YouTube. You say you don't, but you're liars. Every single one of you has access to the internet somewhere in your sphere. Okay? So make sure you do it. Hopefully, nothing will happen, and we will get everything done quite easily by the 23rd. Because there's only one more thing to do with trig. And you're not unintelligent people. If there's a sine law, what must there be? A cosine law. Right? And the cosine law is the exact same thing. It's just a formula. All right? And then finance is 2 days to learn what you need to learn. Everybody cool? Okay. Go. Try 8, 9, 16, and 17. Oh, wait. What's on the back side here? Nah, screw it. That's fine. Just do those. Oh, I didn't realize I had page 214 on here. If you're feeling comfortable, start working. If you're a little meh, maybe you want to watch right now, and I'll go through these ones. Okay? Right? I want to do this so I can work here, yeah? So since this is 8.5 and this is 10, my third side is 20. Could I go down there? Longer than 8.5. Could I go this way? Longer than 10. So what's the only way I can go? Out there. There's my 20. So how many triangles do I have? Only one big one. Yeah, well, we'll talk about that in a second. Right? And then I would solve it. How would I solve it? There's my pair. 20 over sine 58 would give me 10 over sine B. And once I know B, I know that side, then I just do it again. Everybody cool? Okay. A, 71. Give it the side I know, 17. Check Q. Q equals 17 sine 71, which is 16.1. My other side is 17. Or, sorry, my other side is 12. Is 12 less than 16.1? So is it ever going to reach? That's 12. Will it ever reach? If I run it over there, will it reach? If I run it over there, will it reach? So it's, how many triangles are possible here? None. Everybody cool? This one, 35, A, oh, but no, I've changed the letters. So what should I do with this? Can I put 133 here? Why not? Because that's D, so little d has to be over here. So what number goes here? 230. And then I check my Q. Q equals 230 times sine 35, right? Which is 131.9, so 132. Is that bigger than 132? 133 is bigger than 132.
You said it's that big. Oh,
so can it go straight down here? No. Could it go here? Yes, because it's slightly longer than 132. Could it go here? Yeah, because it's less than 230. So I either have this triangle, 35, 230, and then I got to do sine law, or I have this triangle, 35, 230, this is 132, or this is 132, and then you just do sine law. Cool? Now, Jacob, you're like, the obtuse angles are screwing you up, right? Well, okay. Let's work with this one, all right? So this one if I were to finish this triangle up, it would be 132 over sine 35 would equal, let's get this angle, or let's get the obtuse angle, right? So, except I can't. I got to get this angle first. Would equal, let's call that x. That would be 230 over sine x, right? So we do that math. 230 sine 35 divided by 132. Shift sine. So this is 88. Okay? Which makes this 123. Agreed? Okay, now, if I told you that angle D was 123, right? Let's call that D. Across from D would be 133, right? That's why I'm trying to explain it to Jake, because he's like, I'm confused when the obtuse angles happen. So we're saying this angle D was 123, right? That makes that angle D 123 has to be the biggest angle, right? So across from that would have to be 133. Okay, no problem. But wait a minute. How could G be 230? You understand? So that would be an impossible triangle. Now, what if I told you that G was 87? Is that a possible triangle now? Yeah. So we might make that 87, right? If I knew that was 35, then I could do Q and I could check, right? Okay? You good?
So for Q, you would just make the right angle and test it?
You would check this with the 35. But you know it can't be possible if the other side doesn't work with what you know.
I'm just confused of what we would do once we would get Q. So like what do we compare it to for it to...
Okay, well, let's look back at this one when the obtuse angle is here. All right, so we know this is 132, right? So that would be 130, sorry. It was 133, right? So that would be 133 over sine 35 would equal 230 over sine x, right? 230 sine 35. We already know this. Now this is 83, right? Now, does that make any sense? No, right? Where is the 83 in this situation? Where must 83 be?
Like, you mean like in that whole...
It would have to be here, wouldn't it? If that's 83, what does that have to be?
Not 100% sure, but way bigger.
You do know. If this is 83, what's this?
97.
And there's my obtuse angle, still across from the biggest side. Okay? That's what I mean by the ambiguous nature of it, right? When you did sine law here, it told you x was 88. But you know that x cannot be, or no, it wasn't 88, it was 83, right? You know x can't be that. So your calculator is telling you something, but it's ambiguous because it's giving you this angle over here in quadrant 1. But it's this here. That's why this is tricky. That's why I spent a whole day on just the sine law, and then we move on to this, because this will mess you up. But if we set it up the way we know to set it up, this way, it's super easy, right? The only thing that's bugging you is that these ones with the obtuse angles, right? But when we look back at them, and everybody can be working right now, you don't need to be listening to me. When you look back at this first one, angle A is 39. Well, that's not obtuse, so let's look at B. There's our 123. There's only one choice, right? 23, that's less, so it has to be just one solution, right? How could there be two solutions? Well, you would check. You'd have to check them. And no solutions, we already know about a no solution, right? Okay. Do what you can. You've got the rest of today. It's 10:30. It's quite a bit of time. Number 9's a little tricky because it's a range of values, right? So if the third side is between Q and your known side, then there's 2. If it's greater than your known side, there's 1. And this is really the